Just to give you the context of the talk, what I'm going to touch upon briefly about the business drivers for the change. Why do we need to change the way we build networks? Technology options, what we have, followed by some of the next steps, what we should take it in the service provider network. A very brief, high-level view about what we are doing in this space. We've been building networks to connect people with screens and places. So now is the time to connect brilliant machines. These big iron and big data means brilliant machines. Apparently, every single machine on GE portfolio would have a software and analytical capability. What does that mean for the networking? I will take an example of, say, aeroplane engine with 20 sensors, which produces 1 terabyte of data and sends across real time to the back end. That would mean a lot from networking. That would mean we have to think about the way we design the networks, way we deploy the networks, and way we manage those networks. So it's all about people, places, screens, and brilliant machines. So for brilliant machines, we need to have a brilliant networking. What are the 3 foundational technologies? At the infrastructure or transport layer, we clearly see one way or the other, whether you are taking an optical-centric approach or an IP-centric approach, you would be using one or more of these innovations in one way or the other to build your infrastructure layer, to build your transport layer. We have clearly seen the benefits of instantiation of floating software on different hardware in the data center world. And there's no reason why we can't replicate those principles and take those benefits into the networking arena. Whether we call it telco cloud, regional cloud, carrier Ethernet cloud, but the networking functions virtualization is certainly going to be the second big foundational technologies in how we build the future networks. And the third most important and the fundamental reason why we all here is the SDN, giving us the ability to program those devices in real time. So the big question here is, are we there yet? We need to have this technology as mainstream. And before we can get to mainstream, we have to solve all these issues, all these next steps. And we, as Ericsson, are working with our customers, academia, and partners to solve some of those challenges. And I'll briefly outline some of these points which are highlighted here. Scaling for 50 billion devices by the end of 2020. 50 billion Internet of the Things would be there for us to connect. And on top of it, if we have to use the GE example, if we have to create industrial internet, we have to use those analytics on the machines to improve the productivity and create new revenue streams. We will have to think not only the scale, but how we will deal that scale when we're providing these services in a virtualized and real-time manner. So the way we see is the convergence happening on the fixed and the wireless space in a virtualized manner. So which means the networking piece, the infrastructure piece, sort of blends into the cloud IT infrastructure. So if I have to use one word for this, future network would be the ICT cloud. So it will become pretty much cloud ops and cloud infra. So the cloud infra would have, obviously, we would need very fast switching capabilities. We would need virtualization capabilities where the network functions will be sort of extrapolated from the network. And then there will be monetization piece which will be sitting on into the cloud or partially into the distributed cloud orchestrated through the common links over there. I'm the networking guy, and first thing what I learned was stack. So telecom networks today have this implemented in their networks. SDN stack is today more or less from layer 2 to partially to layer 4, although we're starting to see some capabilities around layer 4 to 7, but we're not there yet. So what we need to do is to replicate some of the OSI capabilities into the SDN stack to make SDN mainstream. And one such example, which I've taken here, is deep packet inspection. If I have to do network monitoring, if I have to do load balancing in the network, if I have to do network control, and if I have to do, manage the video optimization. And I was with a couple of our customers last week. The question came was, our cell sites are almost crumbling with the video data. Should we move the content near cell site? What that means when we are virtualizing the network, should we virtualize the content? Should we put the media servers around there? And what if we put the media servers around there, would we have capability to look into the layer 4 or layer 7 ability so that we could cache or we could detect the right flow at the right time and act on that? So having capabilities like deep packet inspection will certainly enable us to do some of those functions. And there is some traction going on in ONF, but we need to step up our game there. Security can be overwhelming, and coming from the networking world, and I think one of my colleagues from BT mentioned security-based SLA on this. And an example of VPN, if you are offering VPN services to your financial data customers, or if you're offering this to the customers who is paranoid about your security, first thing you need, obviously, VPN. Then you need DES or triple DES, AAA, authentication, authorization, accounting, and possibly NAT and access list. Just to get one service up and running, you probably need 3 or 4 security features to be configured on the network, and this is, we are talking about point-to-point connection. So how are we gonna solve this problem? So let's look at SDN principles, how it tackles some of those issues. But of course, there's a need to be done more in that domain. So obviously, having a centralized, intelligent, and control plane helps you to contain the situations very quickly. If you have a reconnaissance attack, denial of service attack, you could pretty much isolate the node, in real time. You could pretty much, contain the impact of the attack by, again, isolating the segment of the network. But you need to have those capabilities to talk not only through open flow. You will have to work with some of the security protocols which are existing in today's network. So this is extremely important. I highlighted here resource, role, and context-based security policies. As a matter of fact, if we can use some of these policies into the NFV cloud, and it paves the path to offer BYOD services. We could have virtual profiles. Those virtual profiles, after they are authenticated, authorized, can be loaded onto the device, and you could offer these enterprise services to the customers. And that might create new revenue streams. Briefly talked about media-aware networking. In the internet, we can broadly classify traffic into four sort of subcategories. We have IPv4 unicast, which is majority of the traffic. We have IP broadcast, which is very dangerous for the networks, but it's still used in a contained manner, one or the other ways, by some of the protocols also. We have IP overlay, which we've been familiar with this for a long time. We have VPNs, VLANs, and whatnot, VXLANs, and now SDN, NVGRE and different principles, which is all on overlay. That's great. What about multicast? Most of the video runs on multicast. Most of the financial data applications runs on multicast. PIM is a very, very complex, control plane protocol. Of course, SDN have an opportunity to offer, better services than PIM, but before it can start offering those services, it will have to interoperate with PIM. It will have to interoperate with those multicast services. If we are thinking about offering media services, to those customers from the NFV cloud, we have to think about interoperability into multicast. One such example where SDN could potentially be used by using different kind of policy metrics, assuming that we have enough maturity around multicast, we could potentially offer these kind of services to our customers in one way or the other. Migration or coexistence, of course, just use the rip and replace approach in a greenfield, which is going to be the scenarios, but not majority of the scenarios is going to fall into that category. So for the end-to-end services, we will have to use migration tools, migration techniques, migration mechanisms which are smart and which are less disruptive to the end services. So if you look at what we call is the radio, router, cloud elements offering the end services, in the radio world, in the router world, in the cloud world, as a starting point, we need OpenFlow to be enabled in all these three elements if we really want to start getting the benefits for the enterprise customers. If we really want to offer BYOD services, if we really want to offer media services, if you really want to offer security services to enterprise customer, if you really want to offer SLA services, lawful intercept, DPI, and whatnot, where you can start making real money. Virtual EPC, virtual home gateway, virtual PE, virtual router, these are some of the enhancement, but it will take time for the carriers to start making money out of these services. But that's where you will start thinking about monetization. So you definitely need that. Coexistence, migration, there's a lot of work done at ONF, and kudos to the migration team, but there's a lot to be done here. So what are we doing in this space? So what we said is radio, router, and cloud. Very briefly, touching upon this, in the radio networks, what we see is, of course, we need bigger spectrum. We need a coordination among the radio resources. But not only among radio resources, but we also need coordination between radio and possibly virtualized NFV network functions and with the cloud with having the common orchestration. In the router world, we heard about virtual routing. We clearly see the way moving forward. And we have the routing guy who just proudly wears the ITF t-shirt here. And then he can talk more about it if you are very keen into knowing about how our routers are gonna transform. Cloud View. So we launched Ericsson. I'm sorry. We launched Ericsson Cloud Manager last year, and we are opening this to third parties. We are working with the OpenStack. We are working with different vendors, and we're working on creating an open sort of a developer framework to have this whole layered architecture. So end-to-end orchestration has been talked quite at length in last couple of days. We would need inter-domain orchestration. In order to offer those services, in order to orchestrate and manage those services, we would need end-to-end orchestration. It is an example which we have taken a model of what is we've been familiar with, almost what we call service chaining, but there will be many such models like service composition, service concatenation, service overlay, service cataloging. So many such mechanisms can be used if you start orchestrating some of these functions. Putting it all together, so infrastructure space, radio, router, and cloud, we are committed towards SDN. Controller space, we are the leading vendors contributing to Open Daylight. And on the cloud execution environment, we are working with our partners, etc. The Open Daylight, Open Forum, DMTF, OpenStack, we are very committed to be part of the open source community. Some final thoughts and key takeaways here. Simplification of hardware is necessary for SDN to be adopted. We've seen protocol oblivious forwarding and many hardware abstraction languages and hardware abstraction techniques, but vendors need to step up their game to also to make sure the hardware is simplified enough for us to be able to use that. Embrace hybrid technologies. We have I2RS, we have Lisp, we have segment routing, we have so many different mechanisms, and we have so many different sort of technologies and standards being offered, we will have to work along with them in the hybrid or coexistence scenarios. Collaboration between standard bodies, tough ask. Guess what? I mean, this is the most difficult one, but I think if we can have a common understanding, at least having some common interfaces between different layers, that will be definitely very beneficial for the industry. Clear northbound interfaces, I think Dan highlighted this in his introductory talk. It was very good to see that traction on that. NFV on the fast track, great news for SDN deployment. I think that will be the place in the carrier network where SDN can be possibly deployed in one or the other manner. Less protectionism. Routers are not going to go away. Only the form factor will change, magnitude will change, their dimensions will change. So if we, as an industry, and we can work together, we have a lot to gain here. And last but not least, service-centric approach. And if we have end-to-end service-centric approach and we work as an ecosystem, strengthen our open source community, I think we can make a differentiator. We have a great opportunity to enable 50 billion devices, brilliant machines, brilliant networks. With that, thank you very much. Thank you.
I think interesting, so Ericsson's a router company?
Yes, we are.
I know, but this is the first time I see it as part of a major positioning. Radio, yeah. Router, and cloud, okay. Thank you.